Hello viewers, welcome to the channel Mr.Zoologist. I'm Sania Javed, student of zoology at University of Chakwal, and I'm going to explain the gas chromatography model. So let's start the video. So what is chromatography? Chromatography is a process for separating the components of a mixture. So this is the basic definition of chromatography. Now moving toward the definition of gas chromatography. So the gas chromatography is a technique in which we determine and separate out the different components of mixture, in which we use gas as a mobile phase and solid or liquid as a stationary phase. So this is the basic definition of gas chromatography. Now moving toward the types of gas chromatography on the basis of stationary phase. So first one is the gas solid chromatography and the second one is a gas liquid chromatography. In gas solid chromatography, if the stationary phase is solid, then it is known as gas solid chromatography. If the stationary phase is liquid, then it is known as gas liquid chromatography. In gas solid chromatography, mobile phase is gas and the stationary phase is solid, and in gas liquid chromatography, mobile phase is gas and stationary phase is liquid. So these are the basic types of gas chromatography. So now moving toward the main principle of gas chromatography. So what is the main principle of gas chromatography? Gas chromatography is a partition. When the sample enter into the sample inlet, it is converted into the vapor phase or the gaseous phase. These sample components of gas phase is linked with the mobile phase, and by the help of partition they are separate out. And now I'm going to explain about the instrumentation and the working of the gas chromatography or the GC. Gas chromatography instrument is constructed by the various parts, which are gas tank, gas tube, gas valve, GC column, GC oven, sample inlet, sample injector, detector, and this one is the recorder. Now coming to the detail of various part of gas chromatography instrument. So first part is the GC tank, is the gas tank, which is made up of from the stainless steel and that contains gas, and gas can be used as a mobile phase, which may be helium, nitrogen, hydrogen, carbon dioxide and air. Among all these gases, helium is commonly used as a mobile phase in gas chromatography. Next part of the GC instrument is the GC controller. So this one is the GC controller. It helps us to control the gas flow rate in GC, gas chromatography. Pressure of the gas should be in the range of 40 to 80 per square inch. Now moving on the GC oven, which is an enclosed chamber and used to maintain the temperature, especially the high temperature, and it can be heated up to 400 degrees Celsius. Now coming to the sample inlet, where we can insert gas or the liquid sample. If the sample is solid, then it will be dissolved in the liquid and converted into the liquid sample, and then it is injected. Next part of the GC instrument is GC column. So there are two major type of columns. So the first one is a capillary column and the second one is a packed column, and the second type is basically the packed column. Generally capillary column is used in GC and length will be 1 to 300 meter. Internal wall of this capillary column is coated with high boiling point stationary phase. And this is the flame ionization detector, and this is the recorder. So here is the instrumentation of the gas chromatography. Now coming to the working of gas chromatography. Firstly, we will open the gas tank valve, then set the pressure of the gas mobile phase at 40 to 80 per square inch. Now the gas mobile phase will be flowing in the GC column. After that, we will inject the sample through the sample inlet. If the sample is gas, then the gas syringe will be used. If the sample is solid, then it will be dissolved in the suitable liquid and converted into the liquid sample. If the sample is liquid, then we will inject the sample through the micro syringe. at the sample inlet. If the gas sample is injected, then it will directly go towards the column. So this is the column along with the mobile phase. If the sample is liquid, then it will be converted into gaseous form due to heat created by the metal block present in the sample inlet. Now, the vaporized liquid sample will move toward the capillary column. When the vaporized sample or the gaseous sample enter into the column and separation is started, according to the boiling point and the size of the molecule, low boiling point compound and the smaller size molecule will show higher affinity with mobile phase and probably elute out faster. As compared to high boiling point compound, and large size molecule will probably elute out later, but some compounds are having very high boiling point are not eluted in the normal condition. In that case we can increase the temperature of oven and increase the elution rate. So this gradual increment in the temperature is called temperature programming, and ultimately eluted molecule move out of the column. Air and hydrogen is also produced. When the eluted molecule reach to the detector, finally chromatogram will be visible in the recorder according to the intensity and the retention time of the compound. We have discussed here the details about the instrumentation and the working of the gas chromatography. Thank you so much for watching this video. For more videos, subscribe to the channel and hit the bell icon.